Hello class, today we're going to talk about lesson 4.4, graphing functions. Our objectives are we can graph functions given limited domains and we can graph functions given a domain of all real numbers. So let's look at our first example. We're going to graph solutions given a domain. So we need to graph the function for the given domain. We've got negative x plus 2y is equal to 6, where the domain is negative 4, negative 2, 0, and 2. So if we have an equation that is not in y equals format, it is a good first step to solve for y since our domain deals with the x. So the first step in doing that is we will add x to both sides. And we will result in 2y is equal to x plus 6. And we have one more step we need to do to isolate the y, and that's divide both sides by 2 since y is being multiplied by 2. So that will result in y is equal to 1/2 x, because x divided by 2 is 1/2 x, plus 3, because 6 divided by 2 is 3. Now we can move on to step 2. So we need to substitute the given values of the domain for x so we can find values of y. So all the domain values we have, we're going to put into our table in our x column. We've got negative 4, negative 2, 0, and 2. So if we plug or substitute each of those x values into our equation, we can find a y value to make our ordered pairs. So let's try that with negative 4. Y is equal to 1/2 times, use the parentheses for multiplication in these types of problems, negative 4 plus 3. Well, 1/2 of negative 4 is negative 2, and negative 2 plus 3 is equal to 1. So our first ordered pair is negative 4, 1. Now let's do that for the other x values. We have y equals 1/2 of negative 2 plus 3. 1/2 of negative 2, that is simply negative 1. And when we add 3 to negative 1, we result in 2. So our ordered pair is negative 2, 2. Now let's do that with 0. Y equals 1/2 times 0 plus 3. 1/2 times 0 is 0, and 0 plus 3 is 3. So our ordered pair is 0, 3. Let's do that with our last domain value, 2. So y is equal to 1/2 times 2 plus 3. Well, 1/2 of 2, or 1/2 times 2, is 1. And 1 plus 3 is equal to 4. So our final ordered pair is 2, 4. Now we can move on to step 3, where we graph the ordered pairs. So now we can graph our 4 points. Because we had specific domain values for our function, we are not going to connect the dots, and we will leave our graph as distinct points. So we are done with example 1a. Let's look at example 1b. Alright, so we have the function f of x is equal to the absolute value of x when the domain is negative 2, negative 1, 0, 1, and 2. We do not have to solve for y since we've already isolated or gotten y by itself. And in fact, in this problem, y is written as the f of x. So let's start with finding values for f of x using our given domain by using a table. So let's start by evaluating the function when x is equal to negative 2. So we're looking for f of negative 2, which is going to equal the absolute value of negative 2. And remember, the absolute value means how far is that number from 0. How many units from 0 is negative 2? That is 2 units, so our first ordered pair is negative 2, 2. Let's do that with the other x values. F of negative 1 is equal to the absolute value of negative 1. Negative 1 is 1 unit from 0, so the f of negative 1 is 1. So we've got the ordered pair negative 1, comma, 1. F of 0 is the absolute value of 0, and 0 is 0 units from 0, so our ordered pair is 0, 0, or the origin. So now let's look at the f of 1, which means we have the absolute value of 1, and 1 is 1 unit from 0, so the ordered pair is 1, 1. Now the f of 2. So we've got the absolute value of 2, and 2 is 2 units from 0. So we also have the ordered pair 2, 2. Now we can move on and graph the ordered pairs. Alright, so let's plot our ordered pairs. Since we had given domain values and our domain was not all real numbers, we cannot connect the dots, so we are done graphing the f of x equals the absolute value of x. So sometimes we're not going to be given specific domain values when we're graphing. We're going to be either told nothing about the domain or that the domain is all real numbers. So if this comes up, we have 3 steps to do. Step 1 is to use the function to generate ordered pairs by just picking several values for x. And I'm going to say pick about 5. And as long as you have 0 and a couple numbers that are bigger than 0 and a couple numbers that are smaller than 0, that should be enough for step 1. Step 2 is then to plot enough points to see if there's a pattern for the graph. And then for step 3, we will connect the points with either a line or a smooth curve. So let's look at example number 2. We're going to graph the function 2x plus 1 is equal to y. Y is already by itself, so we don't need to solve for y. So we are going to pick several values of x and generate ordered pairs by using a table. So we're going to need at least 5 points. So like I said, let's use 0 for sure, and 2 numbers that are smaller than 0, like negative 2 and negative 1, and 2 numbers that are larger than 0, like 1 and 2. So we're going to plug those x values into our function so we can find a y value. We are going to have 2 times negative 2 plus 1. And 2 times negative 2, that is negative 4. Negative 4 plus 1 is going to give us negative 3. So our first ordered pair that we will use to graph is negative 2, negative 3. Alright, let's now use the negative 1. We're going to have 2 times negative 1 plus 1. So 2 times negative 1 is negative 2. And negative 2 plus 1 is going to give us a negative 1. So our next ordered pair is negative 1, negative 1. Now with the 0, we've got 2 times 0 plus 1. It's going to equal, well, 2 times 0 is 0. 0 plus 1 gives us an end result of 1. So our next ordered pair is 0, 1. 2 more points to go. We've got 2 times 1 plus 1. 2 times 1 is 2, and 2 plus 1, that gives us 3. So we've got the ordered pair 1, 3. Last ordered pair, 2 times 2 plus 1. 2 times 2 is 4, and 4 plus 1 is 5. So our last ordered pair is 2, 5. Now we can move on to our next step and plot our points. Alright, let's plot these ordered pairs. Alright, so since we were not given any specific domain values, that means our domain for this function is all real numbers. After we've plotted these points, we do need to connect the dots because of that. So take out a straight edge and connect the dots for your graph. We do need to put arrows on both ends of this line because our domain is all real numbers, which means that this graph needs to be able to go on forever and ever in both directions. So let's look at our next example, 2b. Alright, so for 2b, we've got the function y equals x squared. So we aren't given any domain values, which means the domain is all real numbers. Let's just pick 5 points that will include 0 and 2 numbers that are bigger than 0 and 2 numbers that are smaller. So let's make our table. So since we weren't actually told what domain values we have to use, I'm just going to pick some, like -3 and -1. I always want to use 0. And then let's use 1 and 2. So let's plug those x values into our function so we can get a y value for our ordered pairs. So y is going to equal -3 to the second power, which means that is equal to -3 times -3. And -3 times -3 is a positive 9. So our ordered pair is -3, 9. Let's now substitute -1 in for x. So y equals -1. Let's use parentheses when we are substituting numbers in for equations. -1 to the power of 2 is just -1 times -1, which equals 1. So our ordered pair is -1, 1. Let's substitute 0 in. Y is equal to 0 to the second power, which is equal to 0 times 0. 0 times 0 is just 0. So the ordered pair is 0, 0, or again, the origin. Now let's substitute 1 in. Y is equal to 1 to the power of 2, which is equal to 1 times 1, and 1 times 1 is 1. So our ordered pair is 1, 1. Let's substitute in 2. Y is equal to 2 to the second power, which means we multiply 2 by itself 2 times. 2 times 2 is 4, so our ordered pair is 2, 4. Now we can move on to step 2 and graph the points to see if there's a pattern. So now let's plot these ordered pairs. So if I'm looking at the shape of our ordered pairs, this kind of looks like it might be making a U shape. So let's connect the dots with a smooth curve. It indeed does look like it makes a smooth curve, and we've talked about this shape very little, but this shape is called a parabola. So let's move on to example 3. We're going to use the graph of the function f of x equals 1/3 x plus 2 to find the value of f of x when x is equal to 6. And then we're going to check our answer. So to do this, we're going to go to our x-axis where 6 is and draw a line or an arrow up to the line of our function 1/3 x plus 2. We've found a point where 6 is on the line, and now we're going to draw an arrow over to our y-axis to find out what the y-coordinate is. So it looks like that the f of 6 is equal to 4. So let's check that by using the equation. The f of 6 is equal to 1/3 times 6 plus 2. Now 1/3 times 6 is the same as 1/3 times 6/1, which is going to give us a 2, and 2 plus 2, that is indeed 4, and we have confirmed that the f of 6 is equal to 4. So now we can move on to our last example, our problem-solving application. So the function y equals 2.5x describes how many millimeters sea level y rises in x years. We have to graph the function and then use the graph to estimate how many millimeters the sea level will rise in 3.5 years. So first, we need to understand what the problem is telling us. So our answer is going to be a graph that can be used to find the value of y when x is 3.5. Okay, now let's think of what the important information we know is already. We know we've got the function y equals 2.5 times x, and this represents the sea level rising in millimeters. Now we need to make a plan. We need to think, what values should I use to graph this function? Well, both the number of years and the level of the sea can't be negative, so we're only going to use non-negative values for both of our domain and our range, which means our function will only be graphed in the first quadrant. So now we can look at our third part, which is solving the problem. We need to choose several non-negative values of x so that we can find values of y to graph some ordered pairs. So we should still use the number 0, but then let's just pick 4 numbers that are bigger than 0, since we can't use any negative values. So 2.5 times 0, well, anything times 0 is 0, which means if no time has passed, no years have passed, the sea level would have risen 0 millimeters. Now we can plug in the 1. 2.5 times 1 will equal 2.5, which means if 1 year passes, the sea level will rise 2.5 millimeters. Let's substitute in the 2. 2.5 times 2 is equal to 5. So if 2 years pass, the sea level will rise 5 millimeters. Now we will find the values for 3 and 4. Alright, so now we've got all of our ordered pairs. Now we can go on to our next step and graph these ordered pairs. So we've labeled our graph sea level, we've labeled our x-axis time in years, and our y-axis the rise in sea level in millimeters. So let's graph our ordered pairs. So because there can be fractions of a year and there can be fractions of millimeters, we are going to connect these dots with a line. So now that we have done that, we were asked to use this graph to estimate how many millimeters the sea level will rise in 3.5 years. So we will go to 3.5 on our x-axis and draw an arrow up to the graph of our function, and then we will draw an arrow over to our y-axis. So this looks like it is roughly 8.75. So what we can say is that in 3.5 years, the sea level will rise about 8.75 millimeters. So that wraps up lesson 4.4. For tomorrow, I would like you to finish your turn problems on your guided note packet. See you tomorrow.